A giant car factory with all those robotic arms moving in perfect sync? Or ride a roller coaster and just trust that it's going to stop exactly where it's supposed to? Well, behind almost all of that is an invisible little computer, a tough-as-nails box that's basically the brain of every automated process in the modern world. It's called a PLC, a Programmable Logic Controller. So, what exactly is this thing? And where in the world did it come from?
All right, let's get into it. First, we're going to look at what manufacturing was like before this thing existed. And trust me, it was a mess. Then we'll dive into the invention that changed the game, break down how it actually works, and finally, check out how it's evolved into the powerhouse it is today. So to really get why the PLC was such a big deal, we have to kind of hop in a time machine and go back to the 1960s. We're heading straight for the American auto industry. This was the age of relays, and let's just say controlling a factory was a very physical process. I want you to picture a factory floor with no computers, not a single one as we'd recognize it. Automation was definitely a thing, but it wasn't software. It was this huge, tangled mechanical web of physical switches and timers. So how did they get it all to work? Well, it involved a mind-bogglingly complex maze of wires. You see, the control systems back then were literally hardwired. We're talking cabinets the size of a room, just jam-packed with hundreds, even thousands of little clicking relays. These are basically tiny electromagnetic switches. You also had mechanical timers and sequencers that worked kind of like giant industrial music boxes. Every single action on the assembly line was controlled by a specific wire connecting one thing to another. So what if you wanted to change one tiny step in the process? Yep, an engineer had to come in and physically rewire the whole system. And if something broke, good luck. Finding one faulty relay in that mess could take days. It was slow, it was expensive, and it was unbelievably rigid. So, as you can imagine, the auto industry, especially a giant like General Motors, was just fed up with this. It was a massive bottleneck. They needed something better, something faster, something more flexible. So in 1968, they basically threw down a challenge to the entire engineering world. Find us an electronic replacement for these relay nightmares. And the winning idea came from a pretty small company called Bedford Associates. The hero of our story is an engineer there named Dick Morley, who is now widely known as the father of the PLC. He and his team got to work, and in 1969, they delivered their solution. It was a device they called the Modicon 084. And fun fact, it wasn't a fancy name. It was literally just the 84th project the company had ever worked on. This little box was about to change everything. The name itself, Modicon, was actually genius because it spelled out exactly what made it so revolutionary. It stood for Modular Digital Controller. Think about that. Instead of one giant, fixed, hardwired mess, you now had a modular digital device. The logic, the brains of the operation, wasn't in the wires anymore. It was in the software. Okay, so we've got the why. We know why this thing needed to exist. Now let's pop the hood and see exactly how this magic box actually works. And this right here, this is the whole ballgame. On the left, you've got the old way, relay logic. It's all physical. Control is defined by where the wires go. If you need a change, you got to get your tools out and start rewiring. But on the right, you have PLC logic. Now, control is defined by a software program. That same change that used to take an engineer days of tedious work, it can now be done in minutes, just by editing a few lines of code and uploading it. It's a total paradigm shift. Now, what's really cool is how simple the PLC's core operation is. It just runs on a constant, ridiculously fast loop called the scan cycle. This whole thing happens in milliseconds. So, step 1, it scans all the inputs. Is that button being pressed? Is that sensor blocked? Step 2, it executes the program you wrote, processing all that input data. And step 3, based on the program's results, it writes to the outputs. Turn on that motor, switch on this light, move that arm. Read, execute, write. Over and over and over again, thousands of times a minute. That's the heartbeat of all modern automation. But you know, that first Modicon box back in '69, that was just the beginning. The PLC didn't just stop at being a simple relay replacer. It was about to evolve into the powerful, networked brain of the entire modern factory. Over the next few decades, things really took off. Competitors like Allen Bradley jumped into the market. The programming got way easier, too. They developed graphical languages like ladder logic, which was brilliant because it was designed to look just like the old relay wiring diagrams, so it was super familiar to the engineers. But then came the real game changer, networking. PLCs learned to talk to each other. Suddenly, you could coordinate an entire factory floor, collecting real-time data and laying the groundwork for what we now call Industry 4.0. And today, we even have virtual PLCs that are pure software, running huge processes from the cloud. And here's why all this history matters. That humble invention from the 1960s is still the hidden backbone of our world. It's become this incredibly rugged, reliable industrial computer built to survive the heat, the dust, the vibrations of a factory, and it controls everything from the simplest conveyor belt to the most complex robotic welding arms.
But all of this evolution, all this connectivity, it comes with a new kind of risk. As PLCs got networked, connecting the factory floor to corporate networks and even the internet, they also became a target for hackers. And this isn't a small problem. In 2021, a vulnerability in a major line of Rockwell Automation PLCs was so bad, it got a perfect 10 out of 10 severity score. Suddenly, the security of these industrial brains wasn't just an IT issue, it was a critical safety and economic concern.
Which leaves us with this final, really important question. The PLC took us from the age of clumsy, clicking relays to the modern era of the smart factory. But as these factories get even smarter and more connected than ever before, the biggest challenge is no longer just how we program their brains, but how we protect them.